Hi everybody, welcome to the first lesson of week 2 of distance learning for Gr9 Science. We're continuing with our electricity unit, and this week we're going to be talking about measuring electricity. You built a few circuits last week, virtually at least, and then you saw the charges moving around. Well, now we're going to talk about ways to quantify how much electricity is going through the circuit. So to quantify something means to put numbers to it. And there's going to be three main numbers we're going to be using to describe parts of circuits. So the first thing is called voltage. So the definition is written here. Voltage is the difference in the amount of energy each unit of charge has between 2 points in a circuit. So that sounds kind of complicated. Hopefully I'll be able to clear it up with some examples. But first of all, what you're going to need to start getting used to are symbols and units. Okay, so I said there are three quantities. Voltage is the first one. But for all three quantities, they have a symbol. So this symbol here, it's a triangle with a V. The triangle is called delta. It's a Greek letter. It's capital D in Greek, basically. So this says delta V, and that's what we write as our symbol for voltage. So instead of writing the full word voltage, we're just going to write delta V. And voltage has a unit of measurement, and that happens to be volts. Okay, so voltage is measured in volts, and the symbol for volts is V. So the analogy would be lengths, for example. I would use a ruler to measure the length of something. Okay, and my symbol for length would be L. And the units of measurement for length would be centimeters, or cm. Okay, so you may know some symbols and units for things you may have studied in math, like length, or volume, or area. Now we need to learn the symbols and units for electricity as well. So the first one is voltage. Symbol is delta V, and it's measured in volts. The symbol for volts is V. Okay, so voltage is basically I gave a complicated definition here, but a more simplified version to explain what voltage means, it's the amount of energy, okay? The amount of energy that a battery gives each unit of charge to push it through a circuit. So I took a picture of some batteries I had in my house here. The first one is a AA battery, and if you look really carefully, it's labeled with its voltage. So this AA battery will provide 1.5 volts to a circuit. So that's a measure of how much energy it will give to a circuit that it's connected to. Next is a AAA battery. A AAA battery, if you look really carefully, it also says 1.5 volts. And then we have a disc battery. So this is the battery actually I use in my kitchen scale. Watches also use disc batteries. And this says 3 volts. Okay, so that's how much energy that's being provided to each unit of charge in a circuit connected to the disc battery. And then we have 9-volt batteries, which, as the name tells you, they provide 9 volts. So that provides a lot more energy than these other batteries. Wall outlet provides, in Canada and the US at least, it provides between 110 and 120 volts. So that's a lot more than the little batteries. However, in other continents like Europe and Asia, their wall outlets provide 220 to 240 volts. So if you're going to bring your devices to plug in over to Europe or Asia, you have to make sure you buy a voltage converter. So that'll convert the 200 and something volts back down to 110 to 120 so that your device can operate properly. If you don't, well, first of all, it probably won't even fit. The plugs will not even fit in the outlets in Europe. But if you try to force the plug into the outlet without the converter, then it's going to provide too much energy to that device, and it'll probably damage and destroy the device, maybe even cause a fire. So every time you're traveling out of country, make sure you do your research. Research how much voltage their plugs give out, and make sure you get the appropriate converter. Now in a circuit, so I've got a circuit here. So this battery is providing 9 volts of energy, basically. And that 9 volts is going to push the charges through the circuit. And I've got 3 light bulbs in this circuit. So each one of those light bulbs uses up some of those 9 volts. And these are identical light bulbs, so they're going to be using up the same amount of volts. So they'll each use up 3 volts. So the language we use to describe this is voltage across a battery. Okay, voltage across a battery. That's the energy provided to each unit of charge by the battery. And then we say voltage across a load. And that's the energy used up by each unit of charge when it goes through a load. And I want to try to explain why we use the word across when we describe this. So I'm going to go back to my virtual circuit construction kit. And I'm going to show you how to measure voltage. So over on the right here, I'm going to grab this device, which is called a voltmeter. Okay, and this is going to measure voltage. You can buy these at the hardware store, Canadian Tire, Home Depot. You can use these to measure voltage. We have them at school as well, but we're not at school right now. I do not have one of my own at home, so that's why I have to show you this virtually. So this thing that measures voltage, it's got two needles. Okay, so at the very tip here, these are metal tips, so they conduct electricity. Electricity can run through it. It'll go through these wires, through this machine here, this device, and it's going to display how many volts are going across something. And then these needles have insulating materials, plastic, so that somebody can hold on to them with their hand without messing up the circuit. Okay, so there's 2 needles, so I would put one at one end of the battery, and I would put the other one at the other end of the battery. And then the display will tell me how many volts it is. And it's 9 volts, just like I put in the slideshow. But this picture kind of explains why we use the word across. When we measure voltage, we measure the voltage across something. And that's because there's 2 connection points. Okay, so where I have these 2 needles placed, I'm measuring the voltage from here to here. And we say that's across the battery. Now I'm going to measure the voltage across the light bulb. So I'll disconnect it from the battery. Now I'll put one prong here. And my voltage is not displaying anything. That's because I have to connect the second prong to the other part of the circuit I want, which is the other end of the battery. And now you'll see this is displaying negative 9 volts. Okay, so that's the voltage across the light bulb. It's using up 9 volts. And in the circuit I have in the slideshow, I had 3 light bulbs, so they were using up 3 volts each. So that's voltage. It's how much energy that's provided by a battery, or it's how much energy that's used up by a load, like a light bulb. Okay, the next term I want to talk about is current. Current is a measure of how fast the charges are moving through a specific point in a circuit. It's how fast the charges are moving. And there's a good analogy for this. It's a river current. Okay, so sometimes the current in a river, the water moving in a river, can be very strong. That means the water is moving very fast. But sometimes the current can be very low, so that means the water is moving very slow. Well, we use this exact same word, current, to describe how fast the charges are moving in a circuit. Now, the symbol for current is capital I, so that's going to be a bit tricky. It's not C, okay? It's I. That's the symbol for current, and current is measured in something called amps, and the symbol for amps is A. Okay, so amps is the unit for measuring how fast the charges are going. So I have a couple of pictures here. I'll build these in the virtual construction kit so that you can see it for yourself. But in one circuit on the left, the current says 0.9 amps. The circuit on the right, I've got 3 light bulbs, so the current says 0.3 amps. So the current's a lot faster in the first circuit and a lot slower in the second circuit. And that's slower because it's got 3 light bulbs to push through. Okay, so the light bulbs are going to make it slower. And then resistance. Resistance is the third and final quantity I want to talk about. Resistance is a measure of how difficult it is for charges to push through a part of a circuit. The higher the resistance, the lower the current will be. So the symbol for resistance is capital R, so that makes sense, R for resistance. But it's measured in a units called ohms. It's named after a scientist who did some experiments with electricity. His name is Georg Ohm. And the symbol we use for an ohm is called omega. It's a Greek letter again. It's basically capital O in Greek. It looks like a horseshoe. So if you're trying to draw it on paper, you're kind of drawing a horseshoe when you want to draw ohms. So I have 2 circuits here again. So in the left-hand circuit, this light bulb here, it's a 10 ohm light bulb. That's how much resistance that light bulb is giving. So it's slowing down the charges a certain amount. Whereas on the right-hand circuit, I have a light bulb that's 20 ohms. So this light bulb gives more resistance. Okay, so it slows down the electrons more. That's why you'll see the current on the right-hand circuit is only 0.45 amps, whereas the current on the left circuit is higher. It's 0.9 amps because the resistance is smaller there. Okay, this last slide, this slideshow is available to you on Google Classroom, and it just has all 3 of the quantities with their symbols and their measurements. I've only got a minute left, so I'm going to try to show you this here. So I'm going to attach my current, or I won't. Okay, so I mean, just take a look at how fast the electrons are moving. Okay, and now what I can do is click on the light bulb, and I can change its resistance here. Right now I've set it to 10 ohms. I'm going to change it to 20, and I want you to see how that affects the speed of the electrons. So now it's at 20 ohms, and look how much more slowly they're going. Okay, so resistance slows it down. Got 10 seconds left, so what I'm going to do is I'm actually going to make the battery stronger. Make the battery stronger, and look, it's speeding up the electrons again. All right, I'm out of time here. You got to do a Google